Okay, right. It's record already. Okay, we are ready now. Okay, so before we start our lecture, I need to uh, I need to remind some of the topics. Okay, which regarding to the renewable energy resources. Okay, before I start, let me hold on, yeah, second. Sorry, yeah. Okay, all right. So, look at on our previous topic on the renewable energy resources. I think I've explained to all of you the kind of energy that we have, yeah, right? And then we have the hydro energy, we have the wind energy, and then also we have the biomass. Okay, some of you ask me about the biomass. What is biomass? Biomass is from the living form, from the dead living form or dead biological material. Yeah? So we can use it when after all this thing is decay, then we can use it as a biomass. All right. So there is a term what we call as a biofuel. Yeah, biofuel. For further detail, you can read from all the note here. I will upload the note later on. Don't worry. Yeah. Okay. Right. Then, okay, this is the circle of the biomass. For example, you can have a look later on. And then I've explained to you about the geothermal energy before. Uh, and then this is solar energy, solar panel energy. And then come up with the hydrogen power, all the things. Now, our major concern are, okay, we know already about all this kind of renewable energy. Right. When we talk about energy, we have to notice that there is non-renewable energy and also together with the renewable energy. I explained to you the percentage, yeah, of the non and the renewable energy. Right. Now, the major concern now is how can we store the energy? Now we have energy from all these resources, yeah, from the biomass, from the solar panel, from the geothermal. But the major concern now is how can we store? How can we store the energy? So we can store the energy using a battery. Using a battery. Nowadays, we have many kind of battery. We have acid energy, battery or acid-based battery, and sometimes we have to use the what they call as solid-state battery. A solid-state battery, we refer to the lithium-ion battery. Yeah, lithium-ion battery. So the battery is mainly used to store the energy. Yeah, if you look at on the, I mean, the part of the battery here, yeah, you can see that this is an alkaline battery. Yeah, at the body of this battery, normally what we have the carbon, the graphite, or the carbon rod, and then we have the base here, some kind of chemical thing. We have the manganese oxide, we have the potassium hydroxide, we have the zinc, can and cover with the zinc, yeah, as the anode. All right, and some part are conductor material, some part are insulator. Okay, some part are insulator. Now this is the battery, like the what you call like the normal battery what you have, and for another kind of battery, yeah, which is we call as the lead storage battery, is mainly use a solution, the acid solution here. We have to use the H2SO4 as the electrolyte. Yeah, as the electrolyte. Okay, now we have the cathode and anode, and then we have the plate here. So here we have the negative plate, yeah, which is made from the leads, grid filled with the sponge lead, and then we have the positive plate. Okay, negative and positive, and this is surrounding or immersed. Both all of the plate is immersed inside the solution. This solution we call as electrolyte. All normally we use the sulfuric acid. is a free IC. Yeah. Right. Now we have two kind of battery. We have this battery and this battery. Now before we start, so we in this topic, today topic we focus on energy storage. So this kind of battery we consider as energy storage. Right. So before we start, then we need to look at on some video. I think we need to have a look. Yeah, the concept of this, how the lithium ion work. Now you have to watch this video. Okay, watch the video carefully. Okay, hold on.
Size of its cells and the abs.
Okay, hold on. Sorry, got YouTube.
Hi, Mr.
Okay.
A portable power supply has become the
Sorry.
Adakah anda simpan duit dalam fixed
Hold on,
deposit
yeah.
kerana ia berisiko rendah dan kadar
Okay. Sorry
a
for the
practical
message.
lithium-ion cell also uses an electrolyte and graphite. Graphite has a layered structure.
Now you see, we have the lithium ion, and then we have the electrolyte here, and then nowadays we have the graphite. And I thought maybe some of you have been heard about graphene. Yeah, graphene and graphite is different thing. Okay, this is the graphite structure. Yeah, we have the covalent bond, yeah, one layer of covalent bond, another layer of covalent bond, and then another one. So this is attached by van der Waal, yeah. Right. So this is a graphite, a carbon compound.
These layers are loosely bonded so that the separated lithium ions. Now let's see what happens when you connect a power source.
Okay, this is an overview of the battery. Yeah, we have the separator. Yeah, and then we have this part and this part. Okay, right.
Across this arrangement. The positive side of the power source will obviously attract and remove electrons from the lithium atoms of the metal oxide. These electrons flow through the external circuit as they cannot flow through the electrolyte and reach the graphite layer. In the meantime, the positively charged lithium ions will be attracted towards the negative terminal and will flow through the electrolyte. Lithium ions also reach the graphite layer space and get trapped there. Once all the lithium atoms reach the graphite sheet, the cell is fully charged. Thus, we have achieved the first objective.
So this is the condition one after the battery is fully charged. All the positive ion from here will be migrate to here. Yeah, this part. So this is a fully charged, what you call as fully charged condition. Yeah.
Which is the lithium ions and electrons detached from the metal oxide. As we discussed, this is an unstable state, as if being perched on top of a hill. As soon as the power source is removed and a load is connected, the lithium ions want to go back to their stable state as a part of the metal oxide. Due to this tendency, the lithium ions move through the electrolyte and electrons via the load, just like sliding down a hill. Thus, we get an electrical current through the load. Please note that the graphite does not have a role in the chemical reaction of the lithium ion cells. Graphite is just a storage medium for lithium ions.
Okay, what is the function of graphite? Graphite is in order to store, yeah, the medium of lithium ion. That's it. Yeah. So mean that all the lithium ion will stay or remain over here, store here. Yeah. Okay.
If the internal temperature of the cell rises due to some abnormal.
So it means solid electrolyte. What does it mean? Solid and electrolyte is a liquid form. So when two phase contact each other, we have the term of interface. Mean that this is the interface between the solid and liquid. Okay, this is liquid.
Cell for the first time, as explained above, the lithium ions move through the electrolyte. Here, contributes to the main working of the battery. Even though the SEI layer was an accidental discovery, with over 2 decades of research and development, scientists have optimized the thickness and chemistry of the SEI layer for maximum cell performance.
The battery and so on. So at least you have some idea what is this battery is all about. All right. By that, we can see many components of the battery. So therefore, today's lecture, we will focus on this topic, yeah, which is on the topic of energy storage. All right, energy storage. So we're talking about the thermal conductivity, the insulator application to energy conservation. So in this context, in the battery, we have the conductive material, we have the insulator material. Yeah, and also from the video just now, you heard about something, the word of heat. The heat is a thermal. Yeah, thermal. So before we start, we need to know about the energy transmission mode. Yeah, normally the heat can be transferred. Yeah, in medium, in the liquid medium or solid medium or gaseous medium. The heat can be transferred by three kind of event, which is number one we call as conducting. Number two is convection, and last one is radiation. Yeah, from the radiation, or maybe the combination from all these three. Either conducting. Conducting is normally when you deal with there is an energy transfer, the heat transfer in the solid material. Convection is normally if there is the heat transfer in the liquid form. Yeah, liquid form. For the radiation is more to the air. Yeah. Okay. Right. We look at on the definition of conduction. What is conduction? Okay, in conduction. So we talk about when we talk about conduction, we have the term of electrical conduction. We have the heat conduction. Okay. Now the conduction can be categorized into two. Either if we deal with the heat or we deal with the electric conduction. So in this context, we need to consider by looking at the heat, conduction. Okay. Okay, the heat energy is passed through a solid, a liquid or gas form, molecule to molecule in the material. Okay, in order for the heat to be conducted in solid material, there should be a physical contact. So the material must be contact with each other. So, from the thermodynamic, the first law of thermodynamic, we know that if you have two kind of material, one is cold, one is hot, when you attach together, there will be equilibrium. We call as thermal equilibrium. Yeah. Therefore, thermal conductivity in the measure of speed of heat. So in this context, when we say about thermal conductivity, this term is more to the speed of the heat flow. Yeah, pass through the particle. So in this context, normally heat conduction will be occurred from the hot area to the cold area. So there must be the rate, also the rate of heat flow through the material. So if we have to look at on what kind of material. Sometimes we have the material like copper, zinc, and etc. So the rate of the flow will depend on the heat. The material. Okay. And also there must be a different in temperature. All right. So next we look at on the convection. Convection is more to transfer when the heat transfer in the air or gases or liquid. Gases or liquid. Okay. Right. This we call as, for example, a microwave system. Microwave that you use in the kitchen. That will, the heat transfer in the microwave system is via convection. Last one is radiation. Radiation is more to energy transmission by the form of light. For example, the heat that reaches to the surface of Earth from the sun. Because we know that between the sun and Earth, we have the vacuum. So in this context, the radiation, the heat from the sun reaches to the surface of the Earth via irradiation, what they call as electromagnetic radiation. Okay, electromagnetic radiation. So in this context, this kind of radiation we consider as a light, because light is the electromagnetic wave. Right. Now, this is a radiation. Now, as we know that there are three kinds of heat transfer. Number one, conduction. Number two, convection. Last one is radiation. Okay. Now, we look at on the thermal conductivity and insulation. Now, this, if you look at from the battery system just now, we know that in the battery, there must be a conductive material and there must be an insulator. Okay, right. So the thermal property of the insulator material or other common material is known as, we can measure, okay, the amount of heat transmit flow to any combined or material can be calculated. You can calculate, and then if you look at on this, so we focus on the term of conductivity and insulation. Okay, conductivity means the heat can pass through, while for the insulation is the heat or the electric cannot pass through the material. Yeah. Right. So when we talk about the thermal conductivity just now, right, we need to look at on the term what we call as thermal conductivity here with the symbol of K. So this thermal conductivity is a property of material or the ability of the material to conduct the heat or the electric. That's it. Okay. Right. So this we call as thermal conductivity. If you deal with the electron, okay, we say this is not thermal conductivity, but it's more to electrical conductivity. Yeah, electrical conductivity. Electrical conductivity means that the electron can be conduct via the material. But now as we mentioned on the heat, so therefore in this context we call as a thermal conductivity. So from here, for the thermal conductivity, yeah, we can use what we call as Fourier law, yeah, in order to calculate. And the unit of thermal conductivity is measured in the unit of watt per Kelvin per meter with the symbol of W, okay, for watt, and then we have the K, -1 per Kelvin, and per meter. Per meter means that this is the thickness of the material, represented by the thickness. This is the power. The W is the power, the watt. Kelvin is in the different in the temperature, and the meter unit here is the thickness of the material. Now, if we look at and another term, what we call as the inverse order or the reverse order of this thermal conductivity is known as thermal resistivity. Thermal resistivity. Yeah, this is the inverse order of the thermal conductivity. Yeah, right. Now, if you look at on this diagram, we have, like say, we have the material like with the thickness of D, and then we have the thermal or the heat flow from here, from this part to this part. Right. Now, see, if this is the thermal flow with the power of W, for example, and pass through, yeah, the area with the area, yeah, with the meter square one, and then all the heat here one after pass through, and then the heat will flow from here to here. So this is the hot region, this is the cold region. So as I said just now, the heat will be transferred from hot region to cold region. So mean that this heat will flow through this part and then migrate, transfer in between of the thickness, and then after that it pass through here. Now, talking about this thickness, if this material is made from the metal, there will be no energy loss. Mean that the heat will be, the amount of heat in this part with this part will be equal. But however, if this material is made from insulator, so mean that the heat will not flow to the other side. But if the material have the semiconductor property of heat. So mean that the amount of the heat through here, this part and this part will be a bit different. So in this context, the transfer of the heat, within this thickness is not only depend on the thickness, but also depend on the type of the material. The type of the material. Okay, right. Now, if you put the insulator material here, mean that there is no flow. But if you put with the composite material, for example, so mean that some amount of the heat we trap. Yeah, you imagine if you put some amount of some material like a composite. Composite mean a combination of two material. One conductor is non-conductor. So mean that some energy will be absorbed by this insulator. Some will pass through. Yeah, okay. Right. Now we will talk about this one. A thermal insulator. Thermal insulator is the inverse order of this thermal conductivity. Yeah. Okay. Right. Thermal insulator mean that the reduction of the heat transfer mean that it stop. Either it's reduced or maybe it can stop the heat transfer. So thermal insulator is the reduction of the heat transfer. The transfer of thermal between object in between temperature. So the word, we must notice there is the word of different temperature here. Yeah, the word different temperature here is very important. There must be, the heat will be transferred as there is a different in temperature. One part must be hot part, another one must be cold part. Yeah. So between the object, and also the object must be contact each other. What you call as thermal contact. Thermal contact. So here, when two material with different temperature is contact each other, mean there will be a heat transfer. The heat transfer will be occurred from the hot area to the cold area. So at the end, there we have what we call as thermal equilibrium. Okay, thermal equilibrium. So in this context, thermal insulator is also very important in order to avoid the heat, or maybe overheating. For example, we look at on the car engine. The car engine, there must be a thermal insulator. That's why if you open the car boot and the car engine, you can see some part are metal, some part are made from ceramic. Ceramic is a thermal insulator. For example, if you pour a coffee in a cup, if the cup is made from metal, one cup is from ceramic, which one is hot? That's why all the cup is made from the ceramic material, because ceramic is an insulator or thermal insulator. So then mean that you can hold the cup easily, even though there is a hot water inside the cup. Okay. All right. When you talk about the insulator, insulating capability, and also this insulator also very important in order to what? To store the energy. To store the energy. Yeah. Okay. It's not only avoid the overheating, but also the insulator is capable to store energy. It can store the energy. I will explain to you what does it mean with insulating capability or in storing the energy. Later, I will explain to you. The insulating capability of the material is measured with the thermal conductivity with the symbol of K. Low thermal conductivity is equivalent to high insulation. So this word is very important. Don't ever confuse with the term low thermal conductivity. Mean that if the material have a very low conductivity, it means it has higher insulating. Yeah, higher insulating. If you have high thermal conductivity, mean we have low insulating. It's reverse order. Okay, this word is very important. Low thermal conductivity is equal to high insulating. So insulating here mean that with the represented by the value of R, the R value. Okay, for the R value. Right. In thermal engineering, other important parts or other important property of the insulating material is density and specific heat. Density and specific, because we know density is more to the atomic arrangement. Yeah, atomic arrangement. If the atom is very close, mean that it's very easy to what? To transfer the energy. But if loose, then it's not easy. Okay, and then we have the specific heat. So specific heat capacity. So mean that the ability of the material to store the heat. Right. Now, what does it mean with the insulating capability of the material in storing the energy? Now, we look at on one phenomena. For example, if we are in Malaysia, because in Malaysia we are very close to equatorial line, and then we only have 2 seasons in a year. It's not like in European country. In European country, they have a 4 season. Yeah. Now, in Malaysia or Indonesia, if you look at on the design of the house, for example, okay, most of the house will have more window. Why we have more window? Because we need to cooling down the environment. Yeah, if there is less window, then inside the house will be very hot then. Okay, very hot. But contradictly, if you live or somewhere around European country, yes, we know they are very cold there over there. Yeah? From if you go to UK, you go to US, yeah, the temperature will be dropped to maybe minus sub-zero, go to -5. You imagine, yeah? Right. For example, you go to Cameron Highland, for example, yeah, Cameron Highland. If you go to hilly area, the temperature during night time can be can be dropped to maybe 50, no, below than 15 degrees Celsius. 15 degrees Celsius is very cold then. Yeah. It's like you turn on your air condition then. Okay. Right. If you live in somewhere around the European country, you need to ensure that the window of the house must be insulated. That's why, yeah, in terms of energy consumption in Malaysia, between Malaysia or Indonesia with other European country or US country, or Japan, for example, a cold weather country, the people over there spend a lot of money in order to what? To store the energy. What energy is it? The heat energy. The heat energy. That's why if you look at from the house, the house is in UK or in US. Some of the house have the fireplace. They have a fireplace. Yeah, fireplace. The people we burn, the wood in order to have a heat. Otherwise, they'll be very cold then. So in order to prevent the heat from released to outside of the house, they need to ensure that the window of the house must be insulated like this. Yeah. So see now, even the building, this is the building, for example, we have the brick, the wall, and then between the wall that we put insulator. Why? Because in order to ensure that the heat we trap, the heat from the house that we trap, the house, yeah. While for the glass, there must be double layer. Double layer. Maybe in Malaysia, in our country, so we only use one layer of window. But if you go to abroad, like UK or US, like European country, there must be two glaze of the glass. Two glaze of glass. Why? Because in between of it, we have the air. So the air we trap in between of the window. So mean that this is insulator. So when after the heat pass through here, the heat we trap by this air. Okay, right. That's why we need to have a two layer. Yeah. That's why if you want to rent the house, if you go to UK, if you want to rent the house, it depend on what type of window you have. What type of window you have. If you have a double glaze, then you have to pay more money then. If you only one glaze, they're very cheap. Okay, right. So this is why we need this, because in order to prevent the heat from release. Yeah, this is the one of the important thing that we need to know, or the benefit from the insulator. Insulator in order to preserve the energy. That's why in the battery just now, in the example of the battery, the lithium ion just now, you can see inside the battery there must be insulator. Yeah, and some insulator is not only can store the heat, but some insulator have the porosity, yeah, and then capability have to store the energy. So mean that insulator is very important. Now, if you look at on the concept of the battery, you must notice one concept what they call as the dielectric. Because if you look at on the concept of the battery just now, it's quite similar to dielectric property. Dielectric property. Yeah, what is dielectric property? If you look at on dielectric constant, dielectric material. Now, for example, this one here, if you look at the image, the concept of the battery that we have just now is more to what they call as the dielectric property. Now, in this context, we have this conductor, which is a conductor material. In between of it, we have the insulator material. So the charge we store inside in the middle of the two plates. This is the insulator material. So whereby the charge we store remain over there. Like the lithium ion just now, as I show you just now from the video, the lithium ion we store in the carbon. The carbon in the concept battery, the carbon is very important. Carbon in order to store the lithium ion charge. Yeah, right. Now this is what? This is the conductor. This is the conductor. This is the insulator. Now this is we talk about in the context of the electric. Yeah, right. Okay, where we just now. That's why I mentioned just now. When we say about conductivity, there will be two terms. Either we are referred to thermal or maybe electrical, because all of them are energy. Am I right? Electrical is energy. The heat also energy. Okay? That's why I mentioned just now. Either it is thermal conductivity or electrical conductivity. But in our discussion here, we are concerned on the thermal conductivity. Right. Now, this is an example of the glaze. Yeah. So mean that if the one that I mentioned now, the fireplace, yeah. For example, the fireplace, yeah. Because we are in Malaysia or Indonesia, we don't need fireplace like this. That's why if you go to, European country, there must be a fireplace like this. They burn the fire, they burn the wood, and then the heat will be released here. So the heat will be surround here only. That's why the wall over here must be insulated in order to prevent the heat from release outside. Yeah, it's quite similar if you go to camping, for example. If you go to camping, you go to the mountain, and then you make your tent, your camping tent, and then you make the fireplace. Yeah. So of course you need to put your tent nearby the fire. Yeah. Otherwise you cannot get the heat from the fire then. Right. But unfortunately there is no surround like this, the wall. Yeah. Right. One example is like the people, how the people in Eskimo country, living in igloo. You can tell you of igloo. I think igloo, yeah. Igloo. Like this, the house like this. Yeah. How the people in Eskimo country, even though you know that the glue is made from the brick of ice, but you see inside there is still warm. Yeah. So over here, what the function of this ice? This ice is insulator. So mean that if they burn the fire, the make the fire inside there, so the heat will remain inside this igloo. Yeah. All right. Okay. Now we go next one. Insulator. Insulator is very important here in this context. Yeah. So the keyword here: low thermal conductivity, high insulator capability. So insulation, we look at on the term of insulation. As I said, insulation means that the material will not pass through. The heat cannot pass through, or even the heat cannot pass through. The electric charge will not pass through anything. And then, therefore, you look at on the content of insulation here. If you look at on the car exhaust part, for example, this is car exhaust part. Now you see, some part of the car exhaust is covered by ceramic. The white color one there, this is a ceramic material. You see the car engine. You know that the car engine, one after the engine is operated, mean that the body of the engine is very hot. So in order to prevent the engine from contact with the car exhaust, then we need to put the insulator. The white color one, the insulator, mean that one after if we got the vibration, in the engine we may be a vibration. So in the vibration, mean that this one will be what? Vibrate. This exhaust could be vibrate and heat up with the body of the engine, and then afterward, the heat from the engine will be transferred to the car exhaust. In order to prevent this, we have to put the separator, what we call as the insulator. Right. Now, when we talk about the insulator, the word of this one, low thermal conductivity. Okay, insulator means that low thermal conductivity, or maybe low electrical conductivity. Yeah, all right. Okay, reduce the flux heat. The small k value. If the low thermal conductivity have a small value, mean that the thermal resistivity will be very high. In order to have the higher thermal resistivity values of material, so we need to have a smaller K value. So mean that the property of the conductivity must be as low as we can in order to have the thermal resistivity, higher the thermal resistivity. All right, the thermal resistivity measured using by this unit, and the reverse order of the value is known as R value just now. Yeah, right. Okay, definition, right? Some definition. When we talk about the heat, there is some definition of the heat. Yeah, some parameter that related to the heat. Like number one, we have the heat energy. What is heat energy? Is 1 kilocalorie, which is 1 kilocalorie equivalent to 1,000 calorie, or equivalent to this definition. 1 kilocalorie equivalent to approximately about 4.18 kilojoule. 4.18 kilojoule, yeah? Or you can use the British thermal unit. If you use a British thermal unit, we call as BTU. BTU means British thermal unit. British thermal unit, yeah? Okay, this is one of the property, or the fundamental property of the heat. Talking about the energy, the heat energy, how much energy, the heat that you can have. And then number two is thermal conductivity. Yeah, thermal conductivity. Okay, as I mentioned just now. And then we have another one we call as thermal conductant. Thermal conductant. For thermal conductant, the symbol is I. Okay, thermal conductant with the symbol of I. Okay, right. Right. Then we have the thermal resistivity. As I said, thermal resistivity is the inverse order of thermal conductivity. Okay. Right. The resistivity of the inverse order of thermal resistivity. Right. Then last one, we have the thermal, we call as thermal heat transmission. Yeah. Thermal heat transmission. Okay. Any questions so far? Any questions so far? Any questions? So far, can you understand my lecture? Okay.
No, doctor.
Okay, right. All these are definition. All these thing is the term which are related to the thermal, yeah, okay, all these things. And then we have the permanence of the water vapor, the resistance to water vapor. Okay, but the most important one is this one, yeah, the heat energy, the thermal conductivity, the coefficient of thermal conductivity. Okay, and now in this, as I said, this is in context of the thermal, yeah. If you look at on the context of electrical part or the electric, so it all will be different, yeah. All right. Now, why insulator is very important? You see the main crucial one, as I said. Okay, insulator is very important. In battery, insulator is very important. But if there is no insulator, you put the charge will gone. That's why we need insulator. Back to this concept, this dielectric material. If you for this battery material, like this one, yeah. Now, let's say you have the two electrode here. There is only air or vacuum. How can the charge can store in between of here? No, you cannot do that. Unless if you put one material, what it calls a dielectric material. Now, the charge can pass through here and even can store here. This we call as dielectric. Yeah, dielectric material. Yeah. Okay. That this concept is in order to store the charge. Yeah. If there is no connector here, no material, how can the charge? How can this charge can pass through here? Unless if you move this part toward here, contact each other, then we can have the contact, and the charge will be conducted. The electron will be moved. But if there is a gap, none. Yeah, but we have but very low compared to dielectric material. Then it means that this dielectric material is look like a bridge between these two contacts. If there is no material, no current. And then we put the dielectric material, then the electron will be passed through here, material, and some will be stored as a charge. So now, mean that if there is no insulator, then the charge, how can you store the charge then? Right. Okay. In this context, for when we talk about energy storage, insulator is very important. For example, very simple one, you sleep during night time. You sleep in the air conditioned environment, or maybe you go to the hotel, 5-star hotel. Yeah, normally in the 5-star hotel, the room is the temperature of the room very cold. Of course, you need a blanket. Why you need a blanket? A blanket is insulator. Yeah, you need, of course, you find the blanket in order, and then you cover your body in order to make sure your body is warm, because the surrounding is cold. So in this context, blanket is insulator. That insulator is very important. Okay, right. Okay, this is one simple analogy. Yeah. Okay, use a blanket. Blanket insulator mean that you cover your body with insulator. Mean that you can prevent your body from cold and getting cold. Yeah, that the temperature of your body will be remain steady. Yeah, if there is a insulator, like blanket. Okay. Energy storage. So that in context, insulator very important for energy storage. Energy storage is accomplished by device or physical medium that store energy. Medium that store energy. Yeah, energy storage is accomplished by device or physical medium. Device referred to what? A battery. When you say about device, it's not only battery. There will be many systems of energy storage. But in the common case, we refer this device as a battery. Yeah? But actually, there are many more. Many more systems. Yeah? We can store the energy. Right. The key word here is the insulator is important in order to store energy, to perform as a process. And then later, one after you charging your device, your battery, and then afterward you can use it. Yeah, I mean that the term of energy storage is more to a device or physical medium that store energy to perform useful process at a later time. A device that store energy is sometimes called as accumulator. Accumulator mean that it's collect, accumulate. Accumulate mean what? If we collect one bit by bit, bit by bit. That's why when you perform the battery charging, it take 1 hour. You charge your mobile phone, will take about 45 minutes. Some mobile phone can charge very fast. Some mobile phone, it take longer time. Yeah? Mobile phone, it depends. Some technology, depend on the brand then. Samsung, yeah? Nokia, Oppo, Huawei, yeah? Each technology, they have their own battery system. Some handphone can charge very fast. What make the battery can charge the handphone can charge very fast? Because the technology of the battery. That's the answer. Yeah? Okay? And then you charge how long? 1 hour, 2 hour, 3 hour. It means that accumulate. If the full 1 hour mean that every single minute the charge will be collected. If you charge 45 minutes, then every second the charge will be stored. Okay, how many charge it can store inside there? Until the indicator, then your battery are full. Okay, then mean until full, then that is saturated. Full mean the charge is already saturated. Saturated mean it's fully charged. Then device will cut up and then you cannot charge anymore because the battery is full. No more space for you to store the charge. All right. And energy, when you talk about energy, there will be, I think I mentioned to you, there will be many kind of energy. We have the potential energy, we have the chemical energy, we have the, and also on, yeah? Okay. Right. Now, some technology, as I said, yeah, some technology provide only short-term energy storage. And some other can very long-term to power to gas using hydrogen. Nowadays, the people talk about the hydrogen technology, the methane, and then storage of the heat and the cold, and so on. As I said, it depends on the battery as well. Now, if you look at on the how the technology, the energy storage technology, you can see we have a multi-technique of energy storage. We start with one flywheel. Okay, flywheel energy. I can show you the video later on. The flywheel energy, and then this is for mechanical energy. For mechanical will be more to flywheel. Yeah, flywheel energy. Okay, then we have the battery. The flywheel, it can store in this range up to this range. For the battery, it can store from here to here. Even the charging time, the discharge time, you can see which one is fast. Yeah, discharge time is increased as we move around here to here. Okay, now discharge. What does discharge mean? Discharge mean the energy will be what? Released very fast. So in this context, we need what? Longer discharge time. Longer discharge time is very good. It's very good. Yeah. Okay. Right. Then you see, for the battery, it can cover, can get store power from here to maybe some battery can give you up to 10 megawatt. Yeah. All right. Then we have the compressed air storage. We have the pump storage. I know some of you never heard on this, but it could be that the technology that used in the industrial sector. Yeah, in the industrial sector. But for us, as a a public people, normally we use the battery only, yeah, to store the energy. Then we have the power to gas hydrogen. And last one, we have power to gas synthetic natural gases. So this is more toward to the industrial purposes, a big industrial purposes. Yeah. Okay. Right. Now you imagine, like for example, in nuclear energy, how they store the energy from the nuclear. Yeah. The electrical power that generated from the nuclear energy, then how can the energy is transferred from the reactor to the resident house, for example. Yeah, there must be the cable, power supply cable, but and also there must be a transformer. Yeah, transformer, because all the electrical power that we have, we cannot use all the power, otherwise we will burn your house then. Yeah, that's why we need a transformer. A transformer. When I say transformer, it's not the Optimus Prime in the Transformer movie, not that one. I'm talking about the transformer, the device that we use to change the voltage, yeah, to reduce the voltage. Right. Now this one example, yeah, we have the solar panel power, the wind turbine power. Of course, we need the grid to supply to the building and to the industrial, yeah. Right. So that's why when this system collect the energy, then where can we store the energy? Of course, we have to use the battery. Right. The energy storage. This is one example of the energy storage concept. Sorry, I lost my slide. I need to open it again. This one. Okay, this one, yeah. Right. Now, if you look on this, we have from the, as I said, from the nuclear power, generate the electricity, and then we will distribute this cable, the power supply cable, and then through the, through the maybe some to direct to the house by using the, by using the transformer, and some other they need to store the energy then, yeah, by using the system. So this is one example from the, this from nuclear power. This could be from the geothermal, for example. Yeah, right. So if you look at on the solar panel system, so this one I will explain in detail later on. Yeah. Okay. This is solar photovoltaic array. So we have the direct sunlight straight away and then interact with the solar panel, produce the electron will go, and then electron we produce, and then we have the current here. So, and then we have the what? And then from this electron, we operate this electrolyzer, and then from here we can combine. This is the hybrid. This is one example of the hybrid technology. This is hybrid technology, hybrid technology. So from solar, okay, and then combine with this, and then induct the hydrogen power, and then from hydrogen power, we use the hydrogen to what? To have the fuel power here, the fuel cell. From here, we have the heat, and then afterward, we can create the current. Okay, right. Okay, thermal insulator material is the wide range of a wide range of insulator material is available. However, few meet requirement to modern historic construction. So in this context, we need to select the proper insulator material. Yeah. So this, in order to select the, the suitable material, so we need to consider maybe in term of the cost, in term of the effectiveness, and then the durability, and then and etc. So this is the criteria that we need to consider, in order to select what kind of material we choose to in order to become the insulator material. So in this context, when we talk about insulator, we have varieties of insulator material. Yeah, we have from the this polyethylene board, and then we have this up to here, the fiberglass, and then we have the rock wool, and then the sawdust. Sawdust is from the wood, yeah. And then we have the air space. Now you can see there is a difference of the R value here. Okay, which one is the best? Which one is the best? The best insulator. The best insulator with what? Higher R value or lower R value? Which one? Must be higher R value. Higher R value mean that it can become a good insulator material. And some other example are this one. As I said, the R value of the material must be very high. If the R value is very high, mean that they will be good insulator material. Then we have if you compare several material like this one, this is all the material insulator type material from the phenolic, and then we have cellulose, we have the flag, and then we have up to here. And then you see, yeah, this is the thermal conductivity. Yeah. So see from here, we can see if the thermal conductivity very high, mean that the insulator will be what? Will be lower. In order to have the good thermal conductivity material, very good insulator material, we need the material that have lower thermal conductivity. Lower thermal conductivity. Yeah. So from here, you can choose which one is the good insulator. Good insulator is this material, a phenolic, which is 0.022 watt per meter per Kelvin. So why? Because it has lower thermal conductivity. Lower thermal conductivity mean that what? The heat cannot pass through here. Can pass through, but it's a bit delay compared to others. Okay. And also it's not only depend on the material. Now, let's say we look at only one material, the phenolic here, the best one, yeah, the best insulator. You see, you need to consider about the thickness as well, the depth as well. If the thickness is about 1,000 millimeter, 100 millimeter, and then we have 125 millimeter up to 200 millimeter, you see, the U value here are different. Okay, what is the U value? You have to look at on this one. The U value is this coefficient of heat transmission. Okay, this is the U value. Okay, right. Now from here, what you have just now, the U value here. So mean that if you have a thicker one, now which one is the best? Start from 0.2 up to here. The best one is this one. Thicker is better insulator. Thicker is better insulator. Okay? Now, the analogy is very simple. You compare between thin layer of blanket and we have a very thick one. If you have a thick layer of blanket, when you are getting cold, so you need to have the very thick blanket. Then you can prevent your body to be very cold. Yeah, right. So you need a thick blanket. So in this context, the best insulator is phenolic with the thickness of 200 millimeter. Okay, because we need a very low thermal conductivity. Okay, mean that it can store the energy. All right. So in this context, in this lesson, what we need to notice is insulator is very important. Insulator is very important to store the energy. All right. Now at least we have some basic concept on this. So if you look at on the this one, I have some others note here. Later I can this is the insulator, and then this is one. Okay, this one, and then we have talking when you talk about the U value. Okay, there is another one, as I mentioned just now, hot to cold. This is all the U value. And then they got some more example here. Yeah, UR value and so on. This one up to here. So this one I will can pass through to I will upload later on. So you compare between the, as I said, this is a conductor material, heat conductor material. The copper have very high conductivity material compared to iron, compared to aluminum. This is we going down from here to here. Now this is we look like the insulator is good. Inside this insulator property is good. Then granite, lime, and then glass plaster up to this one. This is the you go down here mean that the insulator property is good. Yeah. Okay. So in this context, as I say, insulator is very important. Insulator is very important. Yeah. Insulator property is very important in order to prevent the. Okay. Right. If you look at on the technology of the battery, this some note and the storage. Yeah. You can read. I can upload later on for this one. Okay. I hope you can read from page 6 down to page I think page 10 is enough. Okay, at least you know on the battery technology. Yeah, battery technology. All right, now if you look at on the this is the power storage technology. Now you look at, as I said just now, we have the technology of flywheel, pump hydro storage. I mentioned just now, instead of we have the battery, we got many more. Yeah, system. And this is the energy storage technology, as I mentioned just now. We have the flywheel, we have the pump hydro, we have this one, we have this one, we have the compressor air, compressed air, we have the air spreader, we have the pump hydro. Okay, and even if you look at this is more to what they call as mechanical energy storage. Okay, mechanical energy storage mean that the energy that produced from the mechanical, like for example, what wind power, windmill power, because windmill power is from the mechanical to electrical. So in this context, we use this concept. Yeah, flywheel. Okay, sorry, I will show you later on. And then we have the start, what we call as electrochemical process energy storage. So in this context, we have what? We have many kind of battery. We have the lead acid battery. This is the common in the car. But you use a lead acid battery, you need to top up every day. Every month, every week, every weekend, you need to look on the battery. Either the battery got the battery or not. I mean we need to check the battery level, the liquid battery level, the electrolyte battery level. Yeah, you need to pour that the solution into the battery part. So this is and then we have some other technology nowadays. They use the lithium ion. Lithium ion is more to solid state battery. Yeah, that's why in the car right now, if you free maintenance, we call it free maintenance. Free maintenance battery is lithium ion. That's why if you look at on the battery technology of the car, you will be getting familiar with one concept, what they call as free maintenance battery. Free maintenance battery is more to lithium ion. Free maintenance means that no need for you to check the battery level compared to this one. And then we have the NAS battery. We have the lead acid battery, zebra battery, fuel cell, metal battery, lithium sulfide battery, lithium sulfur battery, reader flow battery, all technology. All these are considered as under one roof, what they call as electrochemical process energy storage. Right? So, and last one, we have what they call as thermal energy storage. For this thermal energy storage, okay, in this context, insulator is very important, as I said. Yeah. For this system, you need have to have a very good insulator system in order to prevent the heat to be released from the environment. We have the what? We have the xylite, we have the PCM storage, we have the steam accumulator, industrial steam, and so on. And thermal chemical. All this technology are under one roof of what they call as thermal energy storage energy system. All right, now, and then up to here only. Here, okay, this is a comparison. This is another one, what they call as chemical storage. This is quite similar to the previous one. Okay, so you have to read until page 11. Now, as a conclusion, for the energy story, we can divide it into three sections. Number one is under what? Mechanical energy. This one. Mechanical energy storage. This is number one. Mechanical energy storage. Yeah, mechanical energy storage. And then we have, second one is what we call electrical process energy storage. And the last one is thermal energy storage. Okay, now let's have a look on flywheel energy storage. Okay, we have a look flywheel and how the flywheel energy storage look like. Okay, have a look. Okay, have a look. Yeah.
If you want to sell online, make sure you stand out. Go to Wix
A chemical battery is usually our first thought when it comes to energy storage, but another less known but promising solution, and one that far predates any modern battery, is the flywheel. This relatively simple mechanical battery with high power density, high efficiency, low maintenance, long lifespan, and no carbon emissions is quite
So
exceptional.
it's a mechanical part. Yeah. This is more to mechanical energy storage. Okay. Flywheel stand for this wheel. It's called as flywheel.
But how does it compare to other energy storage technologies? As the world shifts from fossil fuels toward renewable energy sources such as solar and wind that aren't available 24/7, energy storage technologies play a vital role in balancing the supply and demand. Lithium-ion batteries are the front runner for consumer electronics, EVs, and grid-scale energy storage, with a global market of $46 billion expected to double by 2026. A dual-function electric motor is used to accelerate the flywheel, which is a rotating mass that stores kinetic energy, and when the power supply is cut off and when
Okay, the key word here for the flywheel is this one. Yeah, rotating mass, this one. This material is rotate and then store the kinetic energy. This is the keyword of the flywheel. Yeah. Okay. When you have the rotating mass, what does it mean? Also relate with the what you call as what the concept of the basic physics. Basic physics. What we have the inertia, Newton first law. Yeah, we have the concept of inertia. Inertia is more related to the density, also related to the mass. Yeah. Okay.
and when the power supply is cut off and when energy is needed, the motor operates like a generator. And the spinning flywheel force drives a device similar to a turbine to produce electricity, consequently slowing the rate of rotation. A flywheel is recharged by using the motor to increase its rotational speed once again. The amount of energy that can be stored in a
Okay, this one formula is it? This is what? This is rotating motion, yeah? We have the kinetic energy, we have the 1/2, we have the what God, this is I value. We have the what? Angular velocity. This is related to inertia. Am I right? Moment inertia. This is moment inertia. That's why I said just now the word of inertia, which is related to what do you call? Newton first law. Right? Inertia, moment inertia. We have the angular velocity. This is angular velocity. Then from here we have the energy then. Okay.
rotational mass is directly proportional to the moment of inertia and the square of its angular velocity. The moment of inertia is dependent on the mass and diameter of the flywheel. So, to increase the amount of energy stored in a flywheel, its mass or size must be increased, or the speed at which it rotates must be increased. The maximum operating speed of a flywheel is limited by the material strength of the flywheel rotor. Since the late 20th century, the modern flywheel, developed expressly for energy storage, known as Flywheel Energy Storage Systems, or FESS, has been mostly used. Flywheel shapes that have been used range from the wagon wheel configuration found in stationary steam engines to the mass-produced discs found in internal combustion engines. Flywheels are mostly designed in two shapes. Solid discs or long cylinders are usually constructed from isotropic materials such as steel, while hollow cylinders or tubes are constructed from carbon and glass fiber reinforced composites. Bearings support the flywheel rotor while allowing it to spin at high velocities. Ball bearings and active magnetic bearings are the two most common bearing types used in flywheel systems. Ball bearings are a simple, more common, and less expensive alternative to active magnetic bearings, but are challenged by the
Okay,
life and load.
I'm thinking now for your second assignment could be in group, yeah. So your assignment must be in group, yeah. So I'm thinking now maybe for your assignment two, I will give you instruction later on, but all of you will be divided into group. So I think for all UTHM students who remain in the campus is no problem because you are already in the campus. To me, I expect that you can work in the group later on. So I expect that you for assignment two, yeah, I will ask you to create a model. Any model, yeah, that is useful to produce the energy, number one, or maybe any model that related to energy storage. You have to construct in the group and then you have to make it a video. But you must have a model. You show the model in the video. I give instruction later on for the assignment two. Okay? Right. So get ready for the assignment two. I will divide you, all of you in the group, yeah? Okay? Now a model like this, yeah, a real model, yeah, okay, a real model, and then you may show into the video. Okay, so I'll give you assignment to later on.
Requirements due to the gyroscopic forces and the friction it generates. Active magnetic bearings levitate and they are free from contact, therefore free from wear, and also helps increase the efficiency due to their minimal losses.
You see the word of leverage. What does the leverage mean? Floating. Yeah, you should have a word of leverage over there just now.
Magnetic bearings, but are challenged by the life and load requirements due to the gyroscopic forces and the friction it generates. Active magnetic bearings levitate and they are
Levitate. Yeah.
free from contact. Therefore,
It's more to what? What do you call it? When you got that one. What material is it? Be related to levitate. Superconductor material.
free from wear and also helps increase the efficiency due to their minimal losses. The flywheel is charged and discharged by a double function motor generator, which is usually attached to the rotor by a hub and a shaft. A wide variety of motor types have been deployed: synchronous reluctance, induction, as well as many types of permanent magnet machines. FESS is housed in a vacuumed enclosure to reduce aerodynamic drag with an battery is the flywheel.
Okay, yeah. In this context, you have to use a vacuum, yeah.
Generator enclosure to reduce.
They use a vacuum here in order to prevent the friction. That's why you put in the vacuum, yeah.
Aerodynamic drag with an energy efficiency that can be as high as 90.
So mean that if you enclose this one in the vacuum, mean that you will have a very good efficiency because you know, in my first lecture in chapter 1, I mentioned to you that eta. This is eta value represented by the efficiency of the energy. I mean, that is the ratio between the input and output. So, in order to have a very good efficiency, I mean that the value must be very close to 100%. So, if you have the 90%, I mean this is very good efficiency. Yeah. Okay. Right. Okay. Next one.
Station utilize flywheels as control moment gyros to stabilize and orientate the spacecraft. Flywheels have been used for thousands of years and originated in the potter's wheel and water wheels, with the best known flywheels dating from the Industrial Revolution, where it was used in steam engines. Modern flywheels have been used in gyro buses since the 1950s, where the flywheel is mounted between the rear engine of the bus and the rear axle. Whenever the bus brakes, the flywheel works as a regenerative brake, absorbing kinetic energy and slowing the vehicle down. In the last few years, Formula One race cars have been using flywheels to provide
I see. If you Formula One fan, there we have the term of KERS. KERS stands for Kinetic Energy Recovering System. Okay, Kinetic Energy Recovering System, KRS. Okay. Okay, where one? Why? When I put this now, show you this one.
before it can solve the task of storing renewable energy
Oh, sorry, this
via
one.
curves, which is
This
few
one.
years, Formula One race cars have been using flywheels to provide a power boost via curves, which is a flywheel spinning at 64,000 RPM that absorbs energy that would be lost as heat during braking. When activated, the flywheel temporarily engages with the car's drivetrain and gives a brief speed boost. Flywheels still need to overcome a significant barrier before it can solve the task of storing renewable energy. Although flywheels have a high efficiency and very short startup time, they are still very expensive when compared to other alternatives and lithium-ion batteries. And with the continuous decline of lithium-ion battery prices, it will be difficult to utilize FESS as a viable energy storage solution except for very specific applications. Some developments that can significantly enhance flywheel performance and make it more competitive with batteries are the development of new materials with high strength and low density, and superconducting bearings, which can reduce the friction loss since it enables increased rotating speeds and decreases self-discharge rates. As electric connected energy storage systems, flywheels must compete with batteries and ultracapacitors on the basis of cost. For low cycle applications such as electric vehicles, flywheels are unlikely
You see,
to engage any
okay,
modern
we
battery
finish on
into the
this.
flywheel.
Okay,
This
right.
relatively simple mechanical battery
Okay, I thought maybe if you have time, so maybe you can look at on the this note, and then you can also find out from the YouTube. Yeah, you can watch from the what is pump hydro, and then you type it, and then you can watch from the video from the YouTube. Okay, I think by that we are finished on our chapter. What chapter is it? This is our chapter 3. Yeah, we are somewhere around chapter 3. So we passed the note for the chapter 2 and chapter 3 by today, and by tomorrow, I think everybody are in on holiday, right? So have a good holiday to all of you. For those who are celebrate Deepavali, so I wish all of you, yeah, for those who celebrate Deepavali, happy Deepavali, yeah, for tomorrow event. Okay, so we stop up to here. So next week we will continue a bit on the solar panel, and then talking about your test. Okay, right, your test. You are in the week 4. As I mentioned, next week will be your test 1. But I give you another extra time. Okay, so next week we start on this photovoltaic, and I will give you your test maybe after this one. Oh, we are in somewhere around week. Is it week 4? Am I right?
Yes, bro.
Okay, which one? So since we are in holiday, everybody are in holiday. Why not? If I give you test 1 by next week, is it okay to all of you? Because if next week only test 1, so I consider our meeting is only for your test 1 only. Yeah, right. So let me stop now. So I will stop the recording. So our class is over, and then afterward you can scan your attendance. Okay, I stop, and then I will upload the video later on. Okay, your test. Can we have a test by next week?